Dyslexia is a wonderful example of an important medical problem that spans both neurology and psychiatry. For us at UCSF, that is a goal, to break down these artificial silos and bring groups of smart, motivated, and collegial people together.
This combination of very sophisticated psychiatry, biological psychiatry, thinking about genes, chemicals, in combination with a very anatomic-oriented and language-based group in neurology is unique. This isn't happening anywhere else in the world.
The integration happens in very many ways. So it can happen in the exam room with a pediatric neurologist and a child psychologist and a child psychiatrist all working together in evaluating a child and coming up with a treatment plan together. It also happens every day in laboratories where you'll have a molecular biologist talking to a computational neuroscientist and then have a psychiatrist right there.
Our mission at the UCSF Dyslexia Center is to understand better, to uncover the devastating pieces of dyslexia so that we can target each of those pieces. So much of research is something that takes place in the laboratory, but it takes a long time for that information to get translated into an actual setting where it's useful.
As a neurologist and as a mother of a dyslexic child, I'm really excited about what we can do here, the novelty of the work we do, combining the technology, the brain science, the imaging, the biology, to really understand the strengths and weaknesses of dyslexia and bring this back to empower families and schools and children.
When we're looking at a child with dyslexia, reading problems don't happen in isolation. It comes with other things. For example, they might have memory issues, learning issues. They might also have attentional issues. What we're trying to do at the Dyslexia Center is to identify their exact weaknesses, but also their relative strengths, so we can come up with this optimal and comprehensive but efficient way to instruct and intervene each child.
One of the things about dyslexia is that it's a family journey. It's not just about the student, but it impacts everybody in the family. My son was diagnosed as a dyslexic learner when he was 6 years old, and he was lucky enough to have attended the Charles Armstrong School, which is a school that specializes in teaching kids who are dyslexic or have other language-based learning issues. I was president of the Board of Trustees, and I started looking around to try to figure out how could we improve our curriculum. I approached UCSF and I said, you know, what's being done out there is not good enough. We need a research center that's driven by the needs of a school so that the outcomes will be very practical. And we need to get those outcomes to happen quickly because we have a crisis.
Our current flagship project is called the Phenotyping Project, and what we're essentially trying to do is take a number of dyslexic children and then studying them in real depth, from the genetics to neuroimaging to cognitive and behavioral, environmental, and social-emotional factors.
Phenotyping refers to the way that we can understand the outward expression of a disorder. We can see the different aspects and piece them out so that we can target them. In a sense, we're subtyping.
When we put that together with the Armstrong School, then we're able to look at outcomes, what happens when we intervene, how to make those interventions better, and we can also work to bring the technology that usually would be isolated to the academic setting and take it to the classroom at the Armstrong School.
One of the things that has the biggest potential for impact on the dyslexic learner is the likelihood that we'll be able to detect and diagnose dyslexia at a much earlier stage, before the symptoms really start.
People talk about it all the time, how you're going to go from bench to bedside. That's what everyone aspires to. There are very few places where it's really happening on a moment-by-moment basis. And part of that is the culture at UCSF, and part of it is the environment that's been built here. And I think in the long run, it's going to be really the key to addressing problems that have been really almost intractable for decades.